All right. Hi, all. This is Guided Practice 20 on section 5.5 on properties of logarithms. So remember, the thing that we want to do with logarithms is we want to be able to expand, we want to be able to put back together, and we want to be able to solve. So if we were to expand this one, I see a fraction here, so I have a top and a bottom. So I want the log of the top, so this is equal to log base 2 of 1. And, then I'm going to subtract the bottom. So minus log base 2 of z squared w. Okay, now the z squared w is now a product. So we want to split that one using addition. So this is going to be log base 2 of 1 minus parentheses, because two things are coming. Log base 2 of z squared plus log of w. Okay. Now we know that what's going to happen is that any term that's in the denominator is going to be negative. So if you want to skip this step, you can do that. If I distribute, I get the log base 2 of 1 minus log base 2 of z squared minus log of w. Now, two things I want to do here. So if I go to my calculator and I take, let's see, this is going to end up being 0, this first term. Now, why? Well, because log base 2 of 1 is equal to 0, because base is 2, exponent is 0, answer is 1, right? What exponent for 2 gives us 1? Well, that's 0. So the log, regardless of the base, of any number for any base, the log of 1 is always 0. Okay, natural log, log base 10, all of them. And then I want to bring down that 2. So 2 log 2 of z minus the log of w. And we're going to leave it like that. Okay. Okay, we're going to expand this one as well. And before I do that, I'm going to go ahead and rewrite this. So this is the natural log of x cubed y to the 5th all to the 1/2 power, right? Because any square root, right, the square root of x becomes x to the 1/2, right? That's how we handle our exponents. Now, I'm going to go ahead and use my property. So I'm going to bring this 1/2 down in front. Then I'm going to split it up into 2. So I'm going to leave the 1/2. Big bracket because I'm about to split this into more than one thing. Then I'll have the natural log of x cubed plus the natural log of y to the 5th. Then I'm going to bring down the individual exponents. So this will be 3 ln x plus 5 ln y. And then last thing, we'll distribute this 1/2 to both the 3 and the 5. So that will give me 3 over 2 ln x plus 5 over 2 ln y. And that will be my final answer. All right. This one we want to express as a single logarithm. So here we go. Let's put these, well, actually the first thing I'm going to do is I'm going to take this one and I'm going to expand it, because I don't like when things are put back together. It's just a little bit harder when we put our fractions back together. So this is the same as log base 3 of x cubed y cubed minus 2 log base 3 of x, and I'm going to change that to y to the 1/3, okay, because the cube root, just like the square root becomes the 1/2 power, the cube root becomes the 1/3 power, minus 3 times log base 3 of x minus log base 3 of y. Okay, let's distribute that before we put it back together. So minus 3 log base 3 of x plus 3 log base 3 of y. Okay, now they all have the same bases, so I can put it all back together. So log base 3 of, now anything that's positive goes in the numerator, anything that's negative goes in the denominator. So x cubed, y cubed goes in the numerator. Oh, before I do that, scratch that. What about those numbers out front? Well, let's put those back up top. So we're going to take this 2 and this 3 and this 3 and put them back up as powers. So this will be log base 3 of x cubed y cubed minus log base 3 of xy to the 1/3 squared minus log base 3 of x cubed plus log base 3 of y cubed. Now we want to put it back together. So log base 3 of x cubed y cubed in the numerator. The x, now I'm going to go ahead and again, I'm also going to distribute this to here and to here. So that's going to give me an x squared y to the 2/3 because I multiply exponents when I have powers to powers. And it's negative out front, so we move it to the bottom. Then an x cubed goes on the bottom and a y cubed goes up top. Okay, from here we're going to simplify our exponents. So this is log base 3. All right, I see that this x cubed and this x cubed are the same and they can cancel. And the y cubes up top can be added together. The exponents can be added together to become y to the 6th. And then we have x squared y to the 2/3. And so then the last thing that we want to do is subtract the exponents on the y. So 6 minus 2/3 is 16 over 3. So this is going to be y to the 16/3 over x squared. So the fractions get a little bit funky there, but otherwise same kind of process. All right, last one that we're going to put back together, and then we're going to solve to, and we'll be all set. Okay, so first thing I'm going to do here is, let's do this one without expanding it and see what happens. So the first thing we're going to do is put the powers back up top. So this will become the natural log of y cubed over x squared minus the natural log of y cubed minus the natural log of x to the 4th y squared to the 1/2 power. Now let's distribute those powers. So that becomes y to the 6th over x squared because I multiply powers minus the natural log of y cubed minus, distribute that 1/2. 4 times 1/2 will be 2. 2 times 1/2 is just 1. Okay, now let's put this all back together. Okay, so we have y to the 6th over x squared. Now minus ln of y cubed, that means the y cubed goes on the bottom. And minus x squared y means those both go on the bottom as well. So we have a y to the 6th on top. If we put together our two x terms, we're going to add those exponents and make it x to the 4th. And then you're taking y cubed and y, add those exponents, that's y to the 4th. And then lastly, we're going to go ahead and cancel 4 of those y's with 4 of the 6 that are on top. That leaves me with 2. So you're going to have y squared over x to the 4th. Okay, so there's that one. Now we're going to use that same kind of property to work here in the to solve for number 5. So we're going to, on this side, put this back together as a single logarithm. So the log of subtraction x plus 2, the positive one goes up top. The bottom one is the x. And then we're going to go ahead and put this 2 back up here. So that becomes 4 squared. All right, and 4 squared is 16. Now we can rewrite our logarithm, right? The base here is 10 to the 16th. And that's equal to what's the argument of our logarithm. Now we can go ahead and try to solve this. So this is multiply both sides by x. And this becomes x times 10 to the 16th, which is a lot of zeros. That's a 10 with 16 zeros. And then we have x squared plus 2. And we want to set this equal to 0. So we're going to move the x squared, the 10 to the 16th times x to the other side. So this is 0 equals x squared minus 10 to the 16th times x plus 2. And then we can solve this. So this is using our quadratic formula. So positive 10 to the 16th plus or minus the square root of 10 to the 16th squared. That's going to be 10 to the 32nd. Minus 4ac, so 4 times 1 times 2 is 8. All over 2a, which is 2. And that's what I'm going to leave it like, okay? That one ended up being really, really big because of that 10 to the 16th. And then lastly, let's work the same kind of thing down here for the number 6. So we're on the left-hand side. Let's rearrange this, put this back together. So that means they're being added. So when I put them back together, I multiply the two arguments. So 3 times negative 4 minus x equals the natural log of, pretty sure this is supposed to have parentheses, 2 minus x. Now they both have ln's, so I can kind of cancel those out and just put what's in parentheses equal to one another. So 3 times negative 4 minus x equals 2 minus x. From here, we can distribute our 3 and get negative 12 minus 3x. And we can add 3 and subtract 2. And that's going to give us 2x and negative 14. Divide by 2, and that's going to give us x equals negative 7. Now we do want to check and make sure that that gives us a real answer up here. So if you plug in negative 7 in here, that's going to give us something that doesn't work. Negative 4, oh wait, yes it does. Negative 4 minus negative 7 is negative 4 plus 7, so that's 3, natural log of 3. And then over here, you have 4 minus negative 7, and that's going to give you 9. And so that works as well. So that is a solid answer.